Alright everybody, now that section 4-5 is sort of in the books for now, we can move on to 4-7. Okay, so again, the order that we're doing all this stuff in is kind of important, and we're going from 4-5, and next we're going to do 4-7. On a side note, we're not even going to do 4-6, but just don't even worry about stuff like that. This is the second section that I think we're going to do this week out of 3. I think we're going to be looking to do this week 4-5, 4-7, and 4-8. Alright, so let's get right into it. Chapter 4 recap. The first, we're going to totally, excuse me, bless me, we're going to totally ignore that little note right there, because we didn't do it yet. But what we did do after that, we turned to solving quadratic equations, and that was 4-5 that we just got done doing, which included examples like this, which are solved with a variety of methods. So far, our methods include the following: factor the expression by dividing out the GCF, we were doing that last section, so as to use the zero product property. We also factored the expression by unfoiling, and then using the zero product property again. Methods 1 and 2 require the equation to be set equal to what? What did we need the equation to be set equal to before we could factor? That, of course, would be 0. And the other method, like definitely the third out of the 3, the third method was getting the x squared by itself on one side and then taking the square root of both sides. Okay? Because taking the square root of x squared pretty much turns it into an x. Okay, taking the square root is the opposite of squaring. Now, solving, usually resulted in 2 solutions. Okay, there was that special situation where we ended up with only 1 solution, but 90 whatever % of the time you end up with 2 solutions when you're solving quadratic equations. Now, just really quick up here, this example, you would solve this by factoring out a GCF. Like that's the method of factoring you would do. There's definitely factoring here by GCF. This problem, I think you should be able to factor by unfoil. I mean, there is no GCF. So you would try factoring by unfoil, and I believe you can. This third example, as it happens, x squared minus 24, that doesn't even factor at all. The way, let's say, x squared minus what? What could that 24 be where you could actually factor this? Because you can't factor x squared minus 24, but what could you factor? X squared minus, well, x squared minus 4, x squared minus 49, x squared minus 16. There's a lot of numbers, but not x squared minus 24. So what you would actually have to do here is this strategy. You'd have to move that term over to the other side, and you'd have x squared Might as well write it down as I'm talking about it. You'd have x squared equals 24, and then you'd have to take the square root of both sides. And so the square root of x squared is x, and then don't forget that you're ending up with both a positive answer and a negative answer. And the square root of 24, obviously we can't do it cleanly. Can we reduce, no, not reduce, I tell a lie. Can we simplify the square root of 24? Yes, we can. It ends up being 2 root 6, but I don't want to linger too much on the past. Let's move on to the future. What if I told you to factor, well, yeah, I mean, I guess so, but first I should say, what if I told you to solve that? What about this equation? Let's solve it. Well, your first plan, your plan A, would be to factor by GCF. There is no GCF. There is no GCF. How about factoring this left side by unfoil? You know, and yeah, I guess I sort of skipped over without really addressing the fact that the very first thing you do is make sure it's equal to 0. I mean, it was already equal to 0, so I guess I didn't even mention it. But yeah, it's equal to 0, and so you try to factor. Now, anyway, back to the unfoil. Can x squared plus 3x plus 15, can that unfoil? Well, that depends on if there's two numbers that multiply to get you positive 15, but they also add up to positive 3. That's not possible. It's not possible. So this doesn't factor. So that's why, I mean, that's essentially what we're doing in section 4.7. So what do you do if none of these methods work? What if you can't factor, or what if you can't get x squared by itself and then take the square root of both sides the way we did up here? What if you can't do that? Well, here we go. Behold the quadratic formula. Hey, that's the title of the section. It's all making sense. This is mostly good news, people. There is literally a formula that'll reveal the answers. Now, it's not a nice looking formula, but it's a formula. It's essentially free answers just by using a particular formula. So, and here it is. Ready? A quadratic equation written in standard form, which I hope you at least sort of remember, is ax squared plus bx plus c equals 0. Ax squared plus b, which, by the way, this already is in standard form. It's equal to 0. That's essentially what standard form of a quadratic equation is. And so as long as this quadratic equation is in that form with the a value and a certain b value and a certain c value, we can solve it with this formula. Here we go. This is so exciting. X is going to equal, you ready? That. Negative b plus or minus big square root of b squared minus 4ac all over 2a. I told you, it's not the nicest prettiest looking formula. I mean, I think it's pretty, but it is a formula. Okay, in fact, you might remember this formula being one of my big wall tattoos, kind of up behind my, like in my Fortress of Solitude area, my desk area. This is one of my wall tattoos. It's a big time formula, and there's actually a neat little song that Mr. Birchanowski taught me, and I will sort of sing it here one time only, and it goes a little something like this. The opposite of b plus or minus square root of b squared minus 4ac, b squared minus 4ac all over 2a. Thank you. Hey, no, thank you. But yeah, that's the formula, okay? And really quick, in case I forget to say it later, please don't be confused by any of these like plus or minus symbols. It literally means that, plus or minus. The plus produces one of the solutions, and the minus produces the other one, which maybe we'll see that more in a second. But let's actually do some examples. I know we didn't really actually get to do this example, but we're gonna do plenty. So here we go. Might as well get started. All right, here we go. Example A. Take a breath. So remember, the first thing you would do is you would look at this and go, "Hey, can I even factor this?" You know what I mean? But that's the usual routine. I'm going to be doing a lot of formulas. So here we go. First of all, it's got to be set equal to 0. If it's not set equal to 0, then you're not going to be able to properly identify what your A, B, and C values are. A is going to be the number in front of the x squared, B is the coefficient in front of the x, and C is that regular constant, and then the other side would have to be 0. So here A would be 1 because 1x squared. B would be -1, and C would also be right there, -1. So now, and I'm not going to plus or minus b squared minus 4ac all over 2a. I'm not going to rewrite the original formula too many times here as we finish up, but so here we go. My b value was -1. So plugging it in right there, and right there, ends up with -1. That's right, -1. And then under the square root, I'll have -1 squared minus 4. Now, what was my A? 1. That's always good. And then my C value is -1. All over 2 times my A value, which was 1. So there we go. At this point, I've plugged in all of my proper A, B, and C value. Okay. Now, one of my main points of emphasis is that even though this is a formula, and formulas are usually like free answers, even though it's a formula, there are certain dynamics of it, or certain reasons that people fail and end up with like the wrong answer. And what I see a lot is where people are a little bit off the mark and end up with the wrong answer, is not properly keeping track or dealing with negatives. Like, look right here. My B value was negative, so I had like a negative, and in here I have like a negative number being squared. If you don't handle that properly, you're not going to end up with the correct final answer. And then also here, look, my C value is negative. That can screw people up when you have like minus 4 times something negative. So again, what I'm saying is don't misplay, all these negatives that you might have. This is actually a really good example because of having a negative B value and having a negative C value. It's a really good example to really analyze thoroughly and go over again or whatever if you need to. On a side note, your A value is like never going to be negative, basically. Like you should go out of your way to make sure your A value is not negative. And I know maybe I'll get into that later, but anyway. So negative 1 is positive 1, plus or minus. And now a negative 1 squared is positive 1. And then this minus, okay, it's really a minus 4 times a positive 1 times a negative 1, and that ends up being positive 4. Negative 4 times positive 1 times negative 1. I think that's how you should play that. It's a negative 4 times that times that. All over 2 times 1 is 2. Now, 1 plus 4 is 5. Okay, now, like I said a couple minutes ago, this plus or minus, that means, like, that's why this ends up being two different answers. One of your answers would be 1 plus the square root of 5 all divided by 2, and the other answer would be 1 minus the square root of 5 all over 2. The plus gives you one answer, the minus gives you another answer. But believe it or not, since this square root of 5 we can't do anything with, the square root of 5 is not nice and clean, nor can the square root of 5 be simplified. I know it might be weird at first, it might take a little getting used to, but that is actually how you're going to leave your final answer. In a lot of ways that's a good thing, but again, it might take a little bit getting used to. That's the final answer. Here we go. Example B. Now hopefully this stuff goes a whole lot faster. X equals negative b. B is 6. Plus or minus square root of b squared minus 4 times a times c. All over 2 times a. Alright? So a is 2, b is 6, positive 6 that is, and c is positive 1. Okay? Remember, it's got to be equal to 0. If, for example, this is where I'll do a little bit of elaborating on this example. Let's say this example was originally presented to you as that. That's the same problem, But before you go ahead into either trying to factor or doing your quadratic formula, it's got to be equal to 0. So you would have had to move this term to the other side to have 0. Anyway, so negative 6 is just negative 6. 36 minus, so it's a negative 4. Oh, I might as well write this down. Negative 4 times a positive 2 times a positive 1, that's minus 8 all over 4. So 36 minus 8 is 28. All right. And look, I am going to probably just, as far as like picking our battles here in this distance learning, right, and with the amount of time we have left, feel free to stop right there, you know what I mean? But what you actually need to maybe see at least once, like I'm not going to hold you to this, me, but I mean, you probably need to see this, you know? The square root of 28 is definitely not clean, but it simplifies to 2 root 7. And even from here, you could actually keep going by dividing the 4 into both of these terms. You know what I mean? Again, do not stress over anything after this, but I'm just showing you what happens. Negative 6 over 4 plus or minus 2 root 7 all over 4. And then I'll just even stop right here, but this keeps simplifying. This reduces, but again, you know, I'm not going to hold you guys to like the highest of standards, considering all the, you know, all of our dynamics going on here. Example C, let's see what happens. So once again, A equals what? 2. B equals 6. C equals 7. And so my formula, opposite of B, negative B, B is just 6, that negative is a part of the formula, plus or minus big square root B squared minus 4 times A times C all over 2A. I know, nasty, but it is what it is. Negative 6 plus or minus. That's 36. You know, remember order of operations. 6 squared is 36. A negative 4 times 2 is negative 8. Times positive 7 is negative 56. All over 4. And so now we can just say that 36 minus 56 is negative 20. All over 4. Now, here we go, people. Big moment right here. What can we do with the square root of negative 20? Well, you need to realize that the square root of negative 20 doesn't make any sense. The square root of a negative number. You can't take the square root of a negative number. Can't do it. So you know what this means? This means that there are no real solutions. If you are faced with taking the square root of a negative number right now, you say that there are no real solutions. Now, in these first couple examples, there were 2 real solutions. Okay? 2 real solutions. But this had no real solutions. You got it? In fact, I'm going to call an audible right now and move on to example F. You'll see why in a minute. A equals 1. 1x squared. Remember, it's ax squared plus b. So b is the number in front of the x. That's negative 10. And c equals positive 25. So here we go. Plugging these numbers into the formula, ooh, b is negative. Negative b. Right? Negative b. Negative negative 10. Plus or minus square root of b squared minus 4 times 1. I can't believe believe I'm out of room here. Times 25. Holy schmoly. All over 2a. So here we go. Negative 10, that's positive 10. When we square a negative 10, we end up with positive 100. No, like, don't misplay all these negatives. Now here we have negative 4 times positive 1 times 25. That's minus 100. All over 2. Now check this out. You end up with the square root of 0. What's the square root of 0? Zero. Okay? So here's what happens. If you end up actually being able to do this square root, you need to kind of take this all the way to the end. So here's what I mean by that. You have to literally break this up into like your two separate examples by doing 10 plus 0 all divided by 2. So 10 plus 0 is 10. Divided by 2 is 5. But choosing the negative, 10 minus 0 is still 10. Divided by 2 is 5 again. Oh, this only had one real solution. So here's something really important right now to understand. Here's what we've noticed so far in these 4 examples. Ready? Ready? Underneath this square root is a very, 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 very important part of the formula. This b squared minus 4ac. We call it it's a very fancy word. Sorry, I mean, it just is. It's not. We call it the discriminant. Okay? You don't need to remember the word so much, but, for your test anyway. But this very, very, very important part of the formula, the part that's underneath the square root, is called the discriminant. And whatever the discriminant is, pretty much dictates how many solutions there are. If your discriminant, okay, so let's get our bearings again here. So example A, if our discriminant ends up being something like positive 5, you end up with 2 answers. If your discriminant ends up being something negative, like negative 20, you end up having no real answers because you can't take the square root of a negative number. And if your discriminant ends up equaling exactly 0, that means you end up having just one real solution, because adding or subtracting 0, there's no difference. You know what I mean? So one more time. If your discriminant ends up being positive, you have 2 real answers. If it ends up being negative, you have no real solutions. And if it ends up being exactly 0, you have 1 real solution. That's important for like certain questions on your homework, okay? I know this video is another semi-long one in the making here, but this is all really important stuff. Example D. A equals 1. B equals what? 6. And and C equals 8. So X equals negative B plus or minus b squared minus 4 times a times c all over 2a negative 6 plus or minus 6 squared. Hey, I know what that is. Minus 4 times 1 is negative 4 times 8 is negative 32. Once again, a big part is being able to keep track of your negatives, 2 times 1 is 2. All right, what do we get? 36 minus 32 is 4. So, there's going to be 2 answers. But now you got to look at your square root and think like, can I do that cleanly? And you can. The square root of 4 is just 2. And if that happens, you need to go all the way USA with this. All the way to your 2 separate final answers. So here we go. Negative 6 plus 2 is negative 4 divided by 2. And then the other answer would be negative 6 minus 2, which is negative 8 all over 2. Okay? Now negative 4 divided by 2 is negative 2. And negative 8 divided by negative 2, is negative 4. All right? So these are your very nice 2 final answers. And you know what that means? You know what that means? You get answers that, well, if your square root can actually be done cleanly, like the square root of 4 or the square root of 0 over here, you know what that means? You know what that means? It means you could have factored. In the first place, you actually could have factored this, and you actually could have factored that. But we didn't. One more example, okay? One more example. Check it out. This is supposed to match ax squared plus bx. I'm going to write it down again. Oh, I knew I couldn't make it a whole. Ax squared plus bx plus c equals 0. So take a look. At least this is already set equal to 0, right? So I know my a value is 1, What's my b value? What's the number in front of the x term? Hey, wait a minute. There is no x term. So you know what that means? That means that b actually equals 0. And that negative 32 is my, because it's the regular number, the constant. Negative 32 is my c value. So here we go. Negative b, which is negative 0, plus or minus square root of b squared minus 4 times a times c. Alrighty? Remember, c was negative. Ooh, remember, keep track of your negatives. All over 2 times a. So check this out. Negative 0, that's just 0. That's gone. So I really just have that plus or minus. Now 0 squared, that's just 0 again. And then check this out. Here we go. Remember, keep track of your negatives. Negative 4 times positive 1 times a negative 32. That's going to be positive, because a negative 4 times a negative 32 is positive 128. all over 2. All right? Just knowing your way around positives and negatives. And so you know what? We have so 0 plus 128. It's just 128. And again, I am going to be totally okay with you stopping right there. But I'm just saying, the square root of 128 absolutely could simplify, and then there'd be some canceling. Once you do that, once you simplify the root 128, there could be some canceling, I'd imagine, with that too. But again, I'm going to pick my battles here in this in the time that we're in. So I know that was a lot. I mean, the good thing is that we're only trying to tackle 3 sections, this whole week, right? So you can kind of not be too overwhelmed, you know what I mean? But again, I want to say one more thing in closing. This quadratic formula, right, will bail you out if it turns out that you cannot factor. If you see something that cannot be factored, this quadratic formula, as long as it's quadratic, can bail you out. But as we've seen, we saw this in number example D, example F, and even in example E a little bit. You know what I mean? We didn't need the quadratic formula to do example D, example E, or example F. We didn't need it. But the quadratic formula works every time. It works every time. Now, most people don't use it except as like a last resort. So even though it will literally work every time on any quadratic equation, whether you can factor or not, the quadratic formula will always work. But again, most people only use it as a last resort. Other than that, just one more quick reminder about how the discriminant, the piece of the puzzle that's underneath the square root, that is what really determines how many real answers you're going to end up with, whether it's 2, which is the norm, or 1, or no real solutions at all.